All right, hello, welcome. Thanks for coming to my presentation. We'll be talking about blockchains and decentralization today. So kind of the theme of this is Gumball machines. Of course, at this point, they're kind of just interesting antiques. Nobody really has quarters in their pocket anymore. But if you've been following what we've been doing with the Lightning Network, obviously I and others believe that this kind of thing will make a comeback. People will invent cool new devices kind of the same type with stuff like Lightning Network and other things. So looking forward to that. Okay, so who am I? So I'm Jarrett. Obviously, you know me through the meetup. Been to most of the meetups in the last little while. So yeah, I've been in the Bitcoin space for a couple years. Involved at this level in the meetup. So my background is I do have degrees in computer engineering. I do have a formal training as a software developer. And after getting my degrees, I've also had a career in the industry, very much in distributed systems type stuff. Working on a data center storage product, and which has sort of a distributed system model, and it speaks with different protocols at a very low level. So that's kind of a relevant background that's not all too different from what we deal with in Bitcoin. Coming from that background, learning about Bitcoin, since I've been up to speed in the space, I've had a large degree of discussions around this topic of Bitcoin and blockchain. I've traveled to other cities. I've been involved in a couple different chat communities. Had lots of fairly deep discussions, also, of course, face-to-face in this meetup. So I've had literally hundreds of discussions in this topic with all types of people. Technical people and less technical people, the beginners, the people that have been in sort of this blockchain space doing ICOs and designing their products and selling their tokens and all that. So I've had a lot of those discussions, and I've put a non-trivial amount of time into listening to people and talking about these topics. More recently, with Forkdrop and Sparkshot, Dean and I have been developing very directly with the software. The Bitcoin D, the Lightning D, and thinking of how we carry that forward into satisfying a customer problem, a customer something that the customers will pay for to use our software. That kind of thing. So yeah, this has been more than a full-time job for several years for me, and I've kind of been very hands-on in a very visceral way working with this kind of stuff. So what I'm trying to say is, I think as far as qualifications go, I do have a very deep amount of qualifications in this particular field, so I can speak with some degree of authority on these topics, I guess if you know me and you've spent time talking to me, I do have fairly sharp opinions, so they will be included in this presentation. But yeah, my opinions are my own. This is me talking. This is not officially the Edmonton Bitcoin Association or anybody involved with that or any of our sponsors or anything. This is just me sharing what I know and what I think. And yeah, you can look me up if you want to see my full resume. Okay, yeah, so I want to get this kind of out of the way, just so there's no kind of misunderstandings. I want to kind of summarize what my beliefs are before I start to justify some of the deeper details. So my take on this whole kind of quote-unquote blockchain topic is what you find is a lot of very grand claims, very ambitious type companies and ideas. And it's papered over with a lot of what I would call technobabble, where there's lots of complicated words and concepts and all that are very difficult to sort through. So one thing personally, in my career as a software developer, and this is an acquired skill, I would say, that probably took me some years, and it's still a skill I'm refining, is when you are having a technical discussion with somebody, it's very, very important to use very precise words and know what you're saying when you use words. You can't use words in a very broad fashion. And that's just efficient, so you can actually communicate and collaborate with people effectively. So kind of my evaluation of a lot of people in the space is they're not working on that level at all. They're technobabbling. They're just using words broadly and not actually meaning a lot. And with that, when you listen to these people talk, they don't have great knowledge of databases or networking and some of the cryptography. So I've studied all these topics fairly in depth. So in some way, yeah, I can spot when somebody is just fudging it. So I think there's a lot of that. Another kind of red flag about this industry is they're very insistent on one particular software architecture, which is a blockchain. And that is kind of backwards. The way if you're designing a product or engineering something, you focus on the customer problem. What problem are you trying to solve? And you work backwards from the problem to find the solution that matches the problem. It's the cart before the horse if you're insistent on the software architecture pattern and then going forward with that to go solve a problem. I think it's just plain backwards. Also, yeah, in these large number of discussions and sharing my opinions and what I think, what I find is I kind of trigger a bit of like an immune system response to some of these discussion circles, where coming in and asking questions and not being credulous kind of leads to people, of course they're very polite in real life, they're nice people, of course, but you kind of receive the signal that they don't necessarily appreciate that level of scrutiny. You're kind of ruining their fun. So I've been on the receiving end of some of this, and in internet discussions where perhaps people's emotions run a bit higher. Some of this name calling, some of this character attacks and all that. It's almost become amusing to a degree when how quickly things kind of turn nasty online when you're discussing things. So again, that's kind of a distraction from kind of the technical competence, whether we know what we're talking about or we're just kind of flame warring at each other online. Kind of the unfortunate part as well is when you drill down on these ideas, it very quickly tends to lead to a shady financial product. So in sort of, in being professional, kind of what we talk of as professions like lawyers and accountants and financial planners and doctors and all these professional fields, they have a large degree of attention paid to conflicts of interest. When somebody's speaking with authority on the topic, but then you find out that they're invested in the thing that they're trying to convince you of, that's what we would call a conflict of interest, and usually a red flag of something unethical going on. Not always. So my own conflicts of interest in this, obviously I'm invested in Bitcoin. I'm a believer in Bitcoin. And I don't invest personally in anything else. Because I find the proposition in a lot of cases very dubious. But yeah, in these fields, they appear to be targeted towards raising money or selling tokens and this sort of thing, which is often, when you drill down, it is as shady as it sounds. That people are promoting their own bag of tokens to sell to somebody else. Also, when you look these people up on LinkedIn, you see kind of their work history, and they've bounced around a lot. Just as a generalization, there's people that haven't stuck to one thing. Maybe they've moved from company to company. They've been part of committees or organizations or all these things, and they seem to be just making a stop in Bitcoin. Bitcoin is just one couple year stop in kind of their career trajectory. And I would point to my own kind of career trajectory of focusing on a fairly specialized thing where I understand it. Whereas here, I kind of expect that these people won't stick around very long. They're just kind of here for the buzzword. You expect another buzzword will come along and they will move on to that. So in general, that's really what I suspect about the field in general. Also, talking to a lot of these people, I think most of the people in this room are kind of geeks. We have kind of geek leanings. We like Bitcoin because on some level it's just kind of viscerally cool to us. You don't know why, we're trying to figure it out, but it's cool because we're geeks. A lot of the blockchain crowd, they kind of poo-poo Bitcoin a little bit. they say, well, Bitcoin was just a prototype. It's a nice little, cute little experiment, but now we're going to move forward with the blockchain and, leave the kids with their fancy little internet money. And, we have the real answer, and the real answer is blockchain. So yeah, that's kind of typical, unfortunately. I think Bitcoin is really cool. And anybody that thinks they've got it figured out, I think, needs to look harder. Okay, so yeah, I got a couple more slides on this bent, and then I'll get sort of into more of a positive discussion of the actual tech. But kind of my analysis, there's sort of this psychological phenomenon that's been noted, particularly in like primitive tribes, when they encounter advanced technology, particularly aircraft. They kind of go down these paths of imitating what they see in a fairly like shallow way. These are headphones made out of coconuts. It's all sticks, and like these are like flight goggles and that kind of thing. They're obviously very impressed. It captures their imagination, but they're still just missing a lot of the understanding that really goes into what is an aircraft, what are sort of the economic things about the advanced civilization that leads to stuff like aircraft happening. It's not enough to set out a runway and summon down planes from the sky. You need it's a lot more advanced than that, and they've missed important parts of the story. And researching this helicopter video was almost too bizarre. I had to include it. So there are these people doing sort of a military ceremony, getting into their helicopter. And yeah, just to fast forward, and they take off and fly away in their helicopter. So from a certain reference point, you can kind of see why that's impressive and cool. But it kind of betrays that they don't really understand helicopters. They're really only imitating it in a shallow way. And yeah, I don't know how serious or the full story beyond that, but it's a noted phenomenon. And if you've ever worked in a corporate environment, there's always some new fad management technique. You get this story that, oh, this worked in this company over there, so we have to go implement their agile Scrum type thing over here, but you do it in this very shallow way. You don't actually understand why this stuff works when it has worked. You're just going through the motions and not really listening to the core message of sort of these philosophies. And it's just like a weird kind of psychological trap that a lot of people fall into. So more or less, Bitcoin was very impressive, going from a value of $0 all the way up to $20,000. And there's lots of little complicated things that go into it. So there's kind of they kind of deconstruct some of the elements and try to apply that to their particular business or scenario and expect to get the same results. And I think they're going to get about the same results as these people. Okay, one more slide on this before I get into some details. So there's this author, Nassim Taleb. I'd recommend all his books. A lot of people in Bitcoin, kind of cite him because there's some very powerful ideas in his books. But sort of this is one of his earlier books. But one of the central idea of this book is the narrative fallacy. So this is another like cognitive bias that's fairly well described by him and others. Where if you have sort of a complicated scenario that you're trying to figure out, lots of data points, it's a very like human tendency to connect those data points with a simple story. So if you have like a complicated, like the king died and the queen died, those are two data points. Somebody can come along and connect those two data points with a story where the king died and the queen died of grief. And you can listen to that story and you'd be like, oh, okay, I kind of get it. But in doing that, you're doing a disservice. You're actually shutting down other lanes of inquiry of all the things that you might need to understand about that event. And this really isn't even an explanation. What does it mean to die of grief? Is that something that the doctor wrote on the death certificate? That's not even really a sensical statement. She died of grief. Was it a heart problem? Was it something else? Did she kill herself? All these other things. Was the time order? Was there years in separation of these two events? By connecting with the story, you're actually reducing the amount of information that's available, that you're shutting down questions that you could be asking, trying to understand that. So putting to Bitcoin, Bitcoin is very, very complicated. People have kind of connected that with the story. Bitcoin is successful because of its blockchain, and that is actually missing all the reasons why Bitcoin is successful, which is a very complicated story in my view. Okay. All right, so that's the first of 3 parts of this presentation. So in the second part here, I want to unpack what I believe are sort of the 5 cornerstones of this blockchain topic. So briefly, yeah, the architecture pattern, lots of discussion around notions of digital identity, time stamping, organizations sharing their data for common benefit, and then also the notion of consensus. So I'm gonna unpack some of these things. Okay, very first thing, I'm gonna explain Git, which is not an easy topic in itself, but I think I will do so adequately. So when Satoshi invented Bitcoin, he used and coined the term blockchain. He had a very specific definition of it. I think we have to admit 10 years later that this word blockchain has expanded to mean other things within this blockchain industry. So I'm not using Satoshi's definition, I'm using the expanded definition of the blockchainers. I'm using their definition. And under their definition, I believe Git is a blockchain. It is a software package which will create you a blockchain. First of all, for those of you that have heard of GitHub, GitHub is a website. I believe it's owned by Microsoft. It's a company that provides a web service portal for Git. It helps you develop software. Git is a piece of software. You don't need GitHub. You can just run it on your computer and do everything without GitHub. So yeah, please don't confuse Git for GitHub. That's kind of a common thing. Okay, so what is Git? Git is a distributed ledger, and what it's tracking is source code updates. So if you're a software development organization, lots of people writing software, each of you have a copy of the software, and each of you are making updates to the software, and you need to share your updates with one another. So in that way, the ledger is software and it's distributed across your team. Git was invented earlier, 2005, 2006, but really, it kind of was ready for mass consumption around 2009, 2010. That's when I learned to use Git. I'd heard of it, but kind of around this era, software developers are like, yeah, we absolutely need to start using Git because it's a good piece of software. In the way that transactions on Bitcoin and other blockchain networks kind of propagate across nodes, flooding out to fill the network, Git uses the same model. So if you have lots of developers writing commits or transactions to the database, you can trade transactions with a peer, and then if that peer trades with another peer, and if you just repeat it from peer to peer, the commits will eventually make it all the way across the network, right? Usually you know what you're getting, so like that guy's writing software, so I'm going to pull his code. But yeah, it's the same kind of concept of flood networking that we see in blockchain. One of the things that makes Git powerful, the thing that is core to the invention of Git in my mind, is this use of SHA-1 notarization of each update. Is it uses cryptography in a fairly advanced way to do what it does, to make sure that people are on the exact same page using SHA-1 hashes. Okay, so you have this distributed ledger, you have developers trading transactions with each other, they're called commits in Git. So then the question is, are these transactions any good? So your tests of whether they're any good is, does the code work? Is it good, readable, well-written code? Does it matter who writes the software? Well, it kind of does, but not in the strict computation sense. You want to know who wrote it because you might want to talk to the person that wrote it. So you can volunteer your information, but identity is not at all required for Git to do its thing. You can be an anonymous Git developer. Many people are out there in the open source world. They have no identity. So this blockchain notion of consensus is part of the process. But this is sort of a new term that kind of through the blockchain lens we've kind of put upon stuff like this. So yeah, no, there is a discussion to be had about consensus, but it's not really that difficult or something that's really concerning in this paradigm. So yeah, that's Git. So those of us that are not software developers, that's fine. But if you're using Git, if you're running Git every day, as I do as a software developer, this is a common window you'll see. This is the Git K tool. This is a visualization of different commits. So this is actually the Bitcoin development. So Git, Bitcoin developers use Git for their software. So what you see here, so these are Bitcoin core developers. So this in dark blue is the SHA-1 hash of this particular commit that this developer wrote and shared. So in his transaction, these green lines are lines that have been added, and the red ones are the lines that have been removed. So this is his transaction on the source code. He's adding some lines, removing some lines. So it has a SHA-1 ID, and then it has a parent and the child. In the same way your blockchain has a block that it's built off of. This commit has a commit that it was built off of, and then subsequently more commits were built on top of it. So that's in the other direction. So you have the SHA-1 IDs of that. Because this is used for software development, it kind of has this notion of branching, where you do have the software being updated and sort of on the main line. However, if you're going to go work on a feature, you probably want to do that on the side before merging that back into the main line. So it does sort of have this notion of branching and then merging. However, that's more just for convenience, because that makes sense when you're developing software. Is what you can do if you really want is just replay these transactions in a very linear fashion. So it's just a straight line, very much like you would expect to visualize a blockchain. Okay, so we're going to come back to Git. This is just an introduction, but I'm just going to cover a few of these other topics first. Okay, so kind of one of the cornerstones of blockchain is identity. Through cryptography, people building these blockchain systems require some notion of identity, of somebody that you can trust as an individual to act honestly in some cases, or at least know how they're acting and tie that back to a cryptographic key. So back in the 1990s, this was a big topic. This was actually a large political topic that, because cryptography has roots in the military, all the way back to Julius Caesar and probably beyond that, right? When armies are coordinating, they encrypt messages to each other. So cryptography has always been sort of a wing of the military. So there came a time in the 90s, once the internet became prevalent, all of a sudden new cryptography was invented, and it was put in the hands of ordinary citizens, not just the military. The Clinton administration in the 90s had a problem with that. They tried to ban it. That's kind of the story of this t-shirt. Somebody wrote strong cryptography and put it on a t-shirt, just so they could walk around with munitions on their t-shirt, classified as munitions, and it's kind of, this t-shirt is classified as a munition. So it was a legal t-shirt because it had cryptography on it. It was kind of the thing. But yeah, anyway, so this was a technology that was a hot topic in the 1990s. What it does is it does encryption, it does digital signatures, so you can encrypt a message, you can sign a message, and it also does identity. So it does actually a decentralized identity system, whereas if I vouch for somebody, if I vouch for Pavel, and Pavel vouches, or sorry, if I trust Pavel and Pavel trusts somebody else, and we can establish that trust by vouching, I sign off, like I trust Pavel, so Pavel signs off, he trusts me. And then if Pavel has another person, I can connect through my web of trust, some degree of trust with that person. I know that Pavel's a trustworthy guy, so therefore somebody that Pavel trusts is also somebody I can trust. So this is something that's been done, and it's been in the wild since the 1990s, and it's more or less proven out at this point. So it's very cool tech. However, I think in the identity research department, I think they've agreed that this is a strong solution to identity. However, The user interface, it has this huge convenience security trade-off. It's a highly secure system, but it's very inconvenient to use. So this is why nobody uses PGP. Is like you can't teach grandma how to manage your crypto keys. Like it just doesn't take off. PGP is a very specialized kind of thing. And there's kind of that core problem in that regular people just don't know how to use it. So in the blockchain space, people are coming up with these identity systems using cryptography. And what I've seen is they don't address any of these problems that are extremely well known and described. So they're doing a lot of stuff to just reinvent this badly, in my opinion. This is a problem that is solved, but it's hard. And they're not really attacking the problems that make this hard. They're coming up with some other thing where they're making all these grand promises and we're going to solve all these identity problems. And I'm just not impressed because I kind of understand the scope of this particular problem, and they don't seem to be actually even understanding the problem that they're working on. So they should all learn about PGP and use that when applicable, or at least propose something new to address these problems, and they don't need a blockchain. PGP can work in a decentralized way without a blockchain. So I'm going to ask them, why do they need a blockchain? Okay, timestamping. So this is another cornerstone. There's entire blockchain projects built around this notion of timestamping, like Factum is one of them. I know there's several others. And I've had this conversation, some health records or legal records or whatever, what if we put them on a blockchain and we get the timestamp of them? This question of, in the business world, there's lots of problems that require some degree of notarization. So why can't we use a blockchain for that? That sounds like an idea, right? The truth of the matter is this is a solved problem with Bitcoin, open timestamps. There's several other implementations. It's actually a fairly straightforward problem. Now the answer rests in something called Merkle trees, which sounds complicated if you've never heard that, but Merkle trees really aren't that bad. If I had a whiteboard, I could probably explain. If you understand hashing, I could probably explain Merkle trees. But it's sort of a wordy answer to why you don't need a whole blockchain. So people have kind of just run with, oh, we're in love with the blockchain and timestamping sounds good, so they've just gone deep into that, and I don't think they're actually all that honest about whether their thing stacks up to existing solutions that are actually very simple and very well understood. Furthermore, there's some kind of core logical problems in this kind of timestamping proposition, in that just because you've timestamped a piece of information doesn't make it factual information. You could stamp lies. You could timestamp multiple copies of the same document with little things changed. And then in the future, you can only reveal the one that suits your interest in the moment by discounting all the the alternate facts that you also timestamped at the same time. So there's this core problem of if you put facts in a blockchain, there's no solution to make testing that they are true facts as opposed to something somebody just made up. The other thing, and I'm not a lawyer, I'm not an expertise, but it's kind of what I understand through people discussing this problem, is that in a legal setting, if you have some sort of legal challenge where the time order of past events is relevant, like who had this thing at the right first, or who said what first, or whatever else, there's lots of techniques that you can do to kind of reconstruct the timeline in the past in sort of a legal setting. If you could get an exact cryptographic answer to what point in time this fact was known, it's kind of like, so what? Like, yeah, that is neat, but how much are you actually solving by that when you just had like witness testimony, you had like internet archive, you had email trails, you had all these various other ways to reconstruct the timeline. We live in a digital world. Facts are recorded all over the place. And you can trust facts. You can subpoena Google, for example, to find out whether an email was sent at a certain time, or Facebook, or or whatever else, or you find out, you could subpoena the cell phone company and find out, what part of town that person was when somebody got murdered or whatever, right? all these information trails are available. The fact that you have a super exact cryptographic information trail isn't all that helpful in the context of we have all this other information. So I question, the overall utility of this timestamping thing, and it happens to be trivial. Okay. All right, so in blockchain, there's this notion of we're going to get companies to share the data with their the other companies in their sphere, like for example, supply chain management. So if you have a supply chain where from crops to the refiner to the grocery store to the consumer, well, let's just put that all on a blockchain so everybody can trace it. Now that actually, similar type patterns were actually an election issue here in Edmonton a couple cycles ago when this was part of his platform of let's open up the databases of the city of Edmonton, like the street map data, the building permit data, all kinds of other things, all the databases that the city has. Let's just publish them, and that allows companies like Google and Amazon and FedEx and Uber and all these other companies that require facts about the city of Edmonton to operate efficiently. They have access to the data, and there's actually some more interesting data that there's an entire meetup group of people that kind of pick apart data sets like this and kind of mash them up in interesting ways. So when a blockchain is proposed as a solution to this, it's like, well, this is already solved. If you want to open your database to let other companies see it, just do it. Like if the case is to be made, and there's a very good case to be made, and it's been done effectively, you just do it. You don't need a blockchain. In fact, a blockchain is an encumbrance. It's kind of a distraction from the fact of if your organization or your government or whatever is producing data, just make the data available and let people figure out cool things to do with it. So yeah, don't need a blockchain for that, in my opinion. Okay, so on this question now of consensus. So coming back to Git, so I described that sort of in the basic level. But Git was developed by Linus Torvalds, who is also famous for Linux. He's the namesake of Linux, in case you didn't know that. So Git was an invention which was a response to the problem that Linus had. So Linus has been developing the Linux kernel since 1991. But carrying forward, it's now developed by several thousand developers all around the world, like every time zone, every language, everywhere. There's people developing source code for Linux, and they need to coordinate across this global organization about more or less what is Linux, what is the code that they're running, what are the changes being made to the code. So Linus had this problem, and they had kind of cobbled together solutions from like source control and different email tools and all that. So Linus had obviously thought about this problem for some time, and he kind of invented this thing called Git. So what Git was is he used cryptography, the SHA-1 hashing thing, and what he understood about diffs and kind of all the workflows and keeping people in sync. And he automated it in sort of this flood networking thing where everything is notarized with the SHA-1 hash. So we have this, as I described, there's sort of this flood networking thing. Developers are sharing commits with other developers, and it's moving across the world. And it gets back to Linus, and Linus makes a judgment call about whether the code's any good, whether it's worked. It's not just him, it's sort of his group of lieutenants and all that. They're examining this code, they're running this code, they're seeing whether it's buggy or not. And the code that's good is blessed by Linus. And he says that this is the SHA-1 ID, this is the tip of the blockchain, this is Linux at this point in time. So in that way it's centralized, because there's a guy named Linus and he decides what is Linux. But on the other hand, it's kind of a decentralized project, because if he screws up, if he does a bad job and he lets bad code in, shoddy code, People are going to be upset. People are going to put pressure on him. Maybe somebody will come along and say, no, Linus is crazy. I don't know what he's doing. I can do a better job than Linus. So this is kind of the decentralized check on his centralization. So you have this movement of thousands of people and also lots and lots of different high-tech companies or whatever that are involved in some level in this project. So if you ask, okay, how centralized or decentralized is this process? I would say it's a little bit centralized and it's a little bit decentralized. So I think we could admit at least there's some component of centralization in it, but it's somewhat decentralized. So what does that look like when Linus chooses Linux? There's all these developers all over the world. He merges it, he chooses which ones are good and which ones are bad through running it, through taking advice from other people and sort of his web of trust. And so he nominates this particuler SHA-1 ID, that's Linux 5.0, and that was earlier this year, 5.0. And so it has a very exact cryptographic answer. You can trace this ledger all the way back to basically 1991 genesis of Linux, where kind of the first lines were written. So this is the contributions of thousands and thousands of people over many, many, many years, and you get sort of an exact cryptographic summation of all that, which is Linux 5.0, signed by Linus Torvalds. So thumbs up, that's Linux. Okay, so that's sort of a tour of a bunch of technology, and that's what I would call, while it is cool stuff, it is fairly pedestrian, let's say. That is kind of boring. Nobody has 3 conferences a year in every city in the world to celebrate this technology. Because it's kind of boring. Like, this is kind of like, shop talk for the computer geeks, right? And it is on that level. It's kind of, this is out of the purview of most people's willingness to care, because it's just stuff that works in the background. The geeks have it under control. They keep working, kind of the fundamental tech of the cryptography and the networking and the databases. There is that kind of came about in those years, and we've just kind of been following Moore's law, but kind of the fundamentals are understood. As I mentioned, when Git came along, that was a really cool invention. Really appreciate it, but that was 10 years ago since I started using Git. It's just another tool in the tool belt. There's not anything exciting about it. You don't have 3 conferences a year in Edmonton celebrating Git. There's lots of people that use Git, but it's kind of boring. So my kind of answer to the question, which I've already given away, so why do people care so much about this blockchain tech? Well, I think it's more or less just a cargo cult trying to imitate and replicate some of the power of Bitcoin, but they're kind of doing it in a shallow way that doesn't really understand. So here's a satellite dish made out of sticks. Okay, so last part of this presentation, I want to kind of dive down on this notion of decentralization, because that's sort of kind of the most popular buzzword. Okay, so in my view, so there's lots of discussion around decentralization, and people will go into these long, wordy arguments, but kind of the fundamental question is your project centralized or decentralized, or if it's on a spectrum, where is it? And so for the Linux example, it's a little bit centralized in that it's Linus making the final say, but it's decentralized in that he has all these checks and balances on his decision making, and he takes lots of advice from lots of people who are competent and have his ear and his trust. So that's somewhere in the spectrum. Now, my belief, which I will hopefully justify here in the totality of this presentation, is that if you kind of let in this little bit of centralization, I think you're in Git territory, or something that's built very much like Git, which is fundamentally not a new invention. It's fairly pedestrian technology. And then even in the city of Edmonton example, where there's some MySQL databases or there's some Oracle databases run by the city, I mean, just the act of publishing those databases allow people to kind of replicate that data and use it for their own purposes. So So yeah, this is kind of the spectrum. Now I want to be protective of this term of decentralized, because I think, you know, Bitcoin, you know, you may have some criticisms where you could say there is some centralization, but I think by far it's the furthest end of this spectrum. There's really nothing like it, including all these blockchain projects that are throwing around this decentralized word. So I think Bitcoin is a very special piece. Okay, so European elections this week. They're ongoing to my understanding. I think, you know, they're voting across Europe. So what they're doing is they're electing 700 representatives to come sit in this parliament. This is the European Parliament. And it is very centralized, and they're not hiding that in their architecture here. That's kind of why I'm including this picture. So yeah, this is kind of the default kind of paradigm of human decision making, right? We get together a committee, we have some sort of hierarchy involved where either it's like one person who's a decision maker, you have sort of this process of voting and you know, democratic type elections and that kind of thing. But it's all in the same genre of centralized decision making. You're reducing it to a smaller group of individuals to make that final call. Much like in the Linux case, it reduces back to the benevolent dictator who is Linus. That's the term they use, benevolent dictator. He gets final say, he's a dictator, but he does it out of his goodwill. So that's centralized decision making. And I'm arguing that that's kind of uninteresting. This is nothing new. We've seen all permutations of this throughout human history. It's not interesting. Okay, so I'm into Bitcoin. I'm into Bitcoin because Bitcoin is specifically not that. Bitcoin is actually a different paradigm entirely. And in that way, it's a very disruptive concept. It's a very new concept, and we're exploring it, but fundamentally it has very disruptive kind of implications to it. And yeah, that's really what attracted me personally to Bitcoin. When I learned about Bitcoin, it's like, I thought I understood computers, but oh shit, there's this new thing that's entirely new, I didn't anticipate it, and computers can just do it now, and that's really cool. And so what that is unlike this, which is a very hierarchical system, Bitcoin presents a radically flat system where hierarchies are rejected by intrinsic nature of the system. So if you'll indulge me for a moment, I just want to dive into some politics and religion, because why not? So this is a photo of actually my personal copy of the book by Leo Tolstoy. So this is written in the 1800s, about 1850. And on the cover it has a picture of Napoleon on his horse. And it's kind of tattered in the cover, but yeah, it's sort of a famous painting that got used. So this is a book, it's a narrative, it's a fictional book, but it's also a philosophical book. And it's obviously been popular and around a long time because it's got some powerful ideas in it. So in this book, he's using Napoleon as a symbol, which I would argue is his era's equivalent of this. This is a centralized authority he's in pursuit of centralized power of all of Europe. You follow me? It's the same picture, just different time, right? In all his magnificence, there's Napoleon. So Tolstoy himself was a Russian nobleman himself, in fact, by birth. And he had rejected that actually to go, be an author and a thinker, and he had sort of, his life's work is kind of talking about the opposite of this. So this title is kind of the pivot point that he's making his arguments against. So just to summarize this 1,000-page novel, it's kind of like Game of Thrones. It's a cheap knockoff of Game of Thrones, I guess you could say. So there's all these Russian noblemen that are doing their nobleman things. They're jockeying for power. They're marrying off their daughters for political advantage, and all these things. And it's happening in the context of Napoleon's coming to conquer Russia. So there's sort of this looming threat of Napoleon coming. And all these noblemen, even though they're on the other side of the war, they kind of have this implicit respect for Napoleon because he's kind of clearly the best at the game that they're playing. So they're all watching, they're all kind of worshiping in a way Napoleon, even though he's on the other side of the war. And it also depicts Napoleon in kind of a bumbling. This is written decades after Napoleon was actually fighting his wars. He was dead for a couple decades, right? So the philosophical component of this book comes in, and he puts kind of a Christian wrapper on it, kind of in some veins of Christianity. There's kind of this notion of a personal Jesus, of you reject the kings, you reject the wealth, you come walk the earth as a simple man. Jesus was a carpenter. He spoke of rejecting all the earthly powers for sort of kind of finding this peace and this is in all Christianity, of course, but kind of this idea that this power, this king, walks with you on the earth. You have a personal relationship with him. It's sort of a decentralized ethic, which is in opposition to the king, the actual earthly powers that have power over the earthly domain. So that's kind of the argument he's making. Now, over here, famously, and by Gandhi's own admission, he was very influenced by Leo Tolstoy. So actually, the young Gandhi went to study with old Tolstoy and really picked up a lot of this philosophy and kind of obviously found sort of a non-Christian interpretation of it. So you can see how Gandhi presents himself. He's presenting himself as a simple man. He's an individual. He's just another person, just like you and me. He's making the case of how to arm yourself with a toolkit to live a peaceful and prosperous life without. And so himself, he's like the polar opposite of Napoleon. He's commanding this power by speaking to the individual, by empowering the individual. And obviously had some degree of success. So in politics and religion, there's sort of this undercurrent vein of kind of this decentralized notion of self-empowerment, very much individual type action. So and this extends into notions like libertarianism and even anarchism. Tolstoy has been even called an anarchist on some level. Certainly, I think he would reject kind of some of the more violent anarchism, the communist revolution and all that. But yeah, sort of on that undervein of individuals and living a happy, prosperous life on this flat hierarchy, I think Bitcoin is kind of made of that same stuff, and it has a very elusive power that's been fairly well described, which is different than that. So yeah, thanks for that indulgence. Okay. All right, rewinding back to the question of Git. So with Git, how do you, or Git in particular in the Linux development, how do you know what is Linux? Well, Linus nominates the SHA-1 hash, and there's sort of a decentralized, if he does a bad job, the checks and balances will find a way to correct that. So in Bitcoin, Satoshi came up with an invention called proof of work. It's a very simple system. It was described in a very short white paper. If you haven't read, here's a section in the white paper on proof of work, which kind of has the first picture of what you recognize as a blockchain. So in this system, there's two rules, more or less. Number one, there's valid blocks. So valid blocks as described by the software implementation. Blocks have to be valid, number one. And number two, it has the most accumulated proof of work attached to those blocks. So if you follow those two rules, you can figure out what is Bitcoin without a central actor. And that to me is the innovation. That is the interesting part of this, is we've done this coordination thing across a globalized system without a central actor. We don't need somebody to nominate the tip. We just follow these two rules and we get the tip. So probably everybody here that's studied Bitcoin a bit has probably heard of the Byzantine generals problem. So this is a computer science problem. It was proposed long ago as kind of an unsolvable problem. This was to solve this problem was attempted in various ways. It had kind of partial solutions that maybe worked in some circumstances, but people kind of agreed this was an unsolvable problem until Satoshi came along and he came up with a very clever sort of economic solution to this problem. So through this rule set of proof of work, even if the network is made up of people that you can't trust, you just assume that they're liars and thieves, like you just reject, you don't need any trust of the rest of the world. If you get a block that's valid and it has the most proof of work, you can establish a system of trust out of a trustless environment. So that is the solution that Satoshi invented, what we call, I guess, Nakamoto consensus right now. Okay, so it follows from that, you get this idea of decentralization. So this is a picture I stole from this article. The author is Stop and Decrypt. He's a prolific person on Twitter. He's written lots of really good articles with cool pictures like this. I'd recommend them. I stole his picture because it was a good picture. But yeah, so every red dot on this diagram is one of these same computers, one of these computers. So everybody distrusts everybody else. So when a miner finds a block and injects it into the network and it propagates through the network, everybody has to validate everything. Everybody's connected to multiple peers at the same time, but they don't trust their peers. They have to check all the answers themselves. And by having lots of interconnection, you can, if there are groups of this network that are maybe malicious, like maybe they're a nation state actor or somebody trying to attack the system, you know, by having all these interconnections, you will get the valid block through perhaps a roundabout route, just by the fact that this is so dispersed and diffuse. But this relies on kind of the notion that everybody validates everything. So that's the decentralized model of Bitcoin. Okay, so with that kind of established, if I had to boil it down to one slide, where the blockchainers get it wrong is they treat the blockchain and this kind of construct as a database discipline. I believe it is not at all a database discipline. I believe it's a networking discipline. This is a solution to the Byzantine generals problem, which is a networking problem. And it is something, for it to work at all as a security model, it relies on robust networking, provided that everybody validates everything. So I believe 100% this is a networking discussion, not a database discussion. So you know, Drake here is trying to make it clear for us. You do not want to store your data in the blockchain. I think you're doing it wrong. What you use the blockchain for is to communicate in reference to value. If everybody has a copy of the Bitcoin blockchain, you can have a communication that references an objective set of facts that you both have. And the Lightning Network is a good example of this, is that nodes can communicate with one another, but it's predicated on the fact that they all have a copy of the blockchain and they all validate every message they get in reference to that. So this is where the magic happens. I think it's very, very much limited in utility as a database. So I'm saying if you're using it as a database, you're doing it wrong, you've missed something. You've got to really think about this instead. So I'm going to try and further convince you of this. So just I want this picture in your head of this very, very diffuse network where everybody validates everything. In order to validate everything, they need to store the data themselves of the past history for them to validate new transactions and new blocks against. They need a certain degree of storage. But the more decentralized your network is, the more expensive data will get. So think of, I don't know how many nodes it is, that's probably a couple hundred. But yeah, I want to do some very simple math to convince you of this. So if you have a picture like this, say 1,000 nodes, and you need to store 1 byte on 1,000 nodes. In aggregate, those bytes will sum up to 1 kilobyte. If you have 1 million nodes in your system, 1 million nodes talking to each other in the system, that's a megabyte. Simple math. Billion nodes, that's a gigabyte. For comparison, a Bitcoin transaction, sort of the simplest version of a Bitcoin transaction is about 250 bytes, but we'll call that 300 bytes. Because there's some variance in there depending on what you're doing. So yeah, 300 bytes. So if you have 1 billion nodes on your network, you're actually using 300 gigabytes worth of storage. Now, for those of you that are familiar with the fees, right, you're paying a fee to the miner as part of your transaction. However, you are not compensating the people that store the data. Okay, so like this is a cost. 300 gigabytes is a non-trivial amount of storage that has to be manufactured for this task. And at that level, it's a non-trivial cost, and it's effectively crowdfunded by the network. So the network volunteers the storage space for your transaction. But 1 billion nodes is not the end of the story. We know for sure that we have more than 4 billion IPv4 devices. Is that the address space of IPv4 has long been used up. And I've heard estimates recently about 20 billion devices is kind of the best estimate we have for devices on the internet. More or less, yeah, 1 billion nodes if Bitcoin is successful, like we hope it is, we're going to get more than 1 billion for sure. And we're probably looking at 100 billion, trillion kind of numbers like that. So storing 1 byte across all those nodes is in fact a fairly daunting proposition. So I think this is a contradiction to some of the motives that some of these large blockchainers have. And so it inevitably will trade off against the decentralization quality of the network. Okay, so you might ask, why do we need 1 trillion nodes? Well, this is very explicitly built into the design of Bitcoin. Is that what we know from the lessons of the internet is that nation-state actors will interfere in the system. So I'm talking right now of like the Great Firewall of China. You can only use services in China that the government sanctions. In Venezuela, I believe, in the last couple months, but in the last couple week or two, there's been civil unrest in Venezuela. The government that's in power, that obviously has control of the telecoms, they blocked Google, they blocked YouTube, they blocked Bing. They are shutting off information from their citizens because, for political gain. That's super contemporary. And other countries have different firewall type things, but China and Venezuela are kind of 2 extreme examples of that. But if you're looking back in history, there's plenty of governments that have gone and interfered with the economy of their nation. So we're talking like Maoist China, Soviet Russia. There's some government that's interfering in the economics of the society, and the result of that is death. This guy, obviously, there's the Weimar hyperinflation that happened, which led to Hitler rising to power. But that was a hyperinflation, so the government that came before him obviously wasn't very good. And it led to, obviously, a lot of people dying. So in Bitcoin, going back to this picture, we want to take away the influence of nation-state actors of what they can have. We don't want them firewalling off their nation from their citizens, and then also injecting sort of alternate facts into the Bitcoin blockchain. We need this to be very well connected and very easy to propagate data throughout the network. And so if you have 1 trillion nodes, we're talking every Gumball machine, every device that has some economic component, something that will handle money in some degree. We got the jukebox, and you can, Pepsi machine, Gumball machine, any device in it. We want a fully validating node. We want that device to be a red dot on this network for the task of resisting the nation-state actors. So radically, every future device that we can with a networking interface is also something we should put a full Bitcoin node on. Okay, so where are we at with that? So this device in the corner, the orange jukebox node that I built, so that is a full implementation. That runs a full Bitcoin node, and it also runs Lightning Network on top of that. So it's the full security model of authenticating the currency and accepting currency at the same time. So if you kind of strip down the parts, like leaving out like the speakers and the screen, all the things that are really strictly involved in validating the coins, that costs about $171 worth of parts Canadian. For reference, something that might be in an arcade machine or like a laundry mat type thing or whatever else, something, what we would call like a coin authenticating machine in the traditional sense, that's about $25. So I believe there's kind of a clear path as stuff gets manufactured better and kind of more special purpose and all that. We can get that cost easily down to something in that realm. if not a lot cheaper in the fullness of time. Minor aside, obviously everybody's phone is a good place to put a node in theory. However, the way that phones are built today, like if you ran a full node on them, they drain your batteries pretty quickly. It has to be doing lots of networking traffic at all times. It has to be hitting the storage and the CPU at a fairly high rate. So right now it's possible but highly inconvenient to run a node on your phone. But as this becomes more common, I think everybody having a full node on their phone is going to be a requirement, and they'll build phones for that. Okay, so obviously the entirety of this presentation is very much in favor of small blocks. And there's purveyors of other lines of thinking where they think the blocks should be very, very large, and they say that you can't possibly scale the small blocks, therefore we need large blocks. I think this position, in my opinion, is becoming increasingly untenable, because we have the working examples. That jukebox there, something I built with my own hands, wrote the software for, can scale. It can run Lightning Network payments. It can participate in this order of magnitude improvement upon the Bitcoin base layer, and do these very, very small micropayments. There's also stuff called side chains. There's different permutations of stuff people are working on with that. And by the way, it's only 2019. Okay, this stuff has been a very, very short slice of time. We've already invented some really cool stuff that address this problem of scaling with small blocks. So I want to say, like, in 5 years, in 10 years, we'll have umpteen different examples of different techniques we can do to scale, such that a device, a low-cost device of that same price point, this price point, wherever it will be, I think we'll be able to do the full security model and be able to transact at scale with small blocks. Okay, so we've made the network very hard to be coerced by a nation state. However, people have pointed out, okay, there's a contradiction, because we actually need to upgrade the system if there's a bug, if there's a needed feature or something like that. So aren't we just defeating ourselves? How do we upgrade if it's resistant to coercion? So the truth is actually, I don't think this is that hard of a problem. This isn't really a big contradiction to resolve. So the example I'm going to use is DNS. So that's a domain name system. So that's where you take like a URL web domain, like edmontonbitcoin.org. You query via DNS to a DNS server, and it tells you, okay, edmontonbitcoin.org is this website over here. So here's the IP address, go talk to this guy. So it's this very, very important protocol that really, like, at this point, like, civilization rests on this. I'm sure everybody's used DNS 100 times today to look up a website or do what you do on your phones and in your computer. So this is a super, super important, super widespread protocol that's the size of the internet itself. And they were actually able to upgrade it. They actually changed, what we would call a hard fork of DNS. Took effect February 1st, 2019. So how was that done? Well, they set a flag day. That was the day. It was something that had been clearly described as a problem in DNS. Like, there was some stuff that was broken about it that basically everybody could look at with an honest eye and say, yeah, that's broken. We need to fix that. They moved very, very slowly. They put this date out into the future, and they went through this effort to minimize disruption leading up to the flag day of February 1st. So February 1st is now in the past. This upgrade took effect. I didn't even know about this till later. So they did a very successful job on minimizing disruption. Apparently some stuff broke, but it was a bad day in the office for the IT people, so they stayed late and they fixed it, no problem. So yeah, we upgraded DNS, which is this hugely important protocol. So I would argue no problem. All right, let's summarize and wrap this up. So in my view, Linus Torvalds in Git, I believe that was a significant invention that was used cryptography effective to address his problem of sort of this distributed coordination around the world, where he needed a certain degree of exactness and auditability and all the properties of a blockchain. So Git, I think, was a fantastic invention, and it worked for source code, and I believe in a similar way, you could do it for other types of data, your logistics data, your supply chain, that kind of thing. Instead of source code, you could put all that in Git and have a good time, and you could use it as effectively as Linus. Satoshi came along roughly the same time, maybe not directly influenced, but certainly sort of on the same kind of plane of thinking. He invented Bitcoin for a subset for the transactions of Bitcoin itself. He came up with economic incentives that allowed there to be no central figure. So we subtracted Linux out of this. Now, this is where the blockchain discussion has lost me, unfortunately. So I'm leaving a big bold question mark. And my belief is all the stuff that's going on here is a lot of noise. It's not really clear what they're talking about. If you deconstruct the tech, at best they're talking about Git or some realm of predecessor technology. There's all this notion of cult figures and committees and politics, and literally they bake that into their protocols in the cases of some blockchain things. They make unlimited blue sky predictions. We're going to store all things in our database and it's going to be great, up to including real-time StarCraft data. That was something Vitalik said at one point. That's total nonsense. I don't even know how to parse that thought. And yeah, they just hard fork when they want, and there's sort of all this cult kind of action. And yeah, it's all in the realm of this kind of centralization. They apologize for their centralization and they try to rationalize their centralization away. And I believe at best that just gets them back to over here. So to me, that's uninteresting. Okay, last slide. Just to wrap it up, I believe a lot of this blockchain discussion is largely noise and nonsense. As a qualified person, I've put a lot of effort into deconstructing all that's going on there. I think there's not a lot of merit, and just my read of kind of the buzzword enthusiasts that are make up that space, I have to conclude that a lot of those people will probably evaporate off. I mean, I don't know what a bull run in price in some of these currencies might do, but I think it's kind of ultimately doomed to evaporate off. Is we need to find real technology and real implemented solutions that add value to people's lives for it to stick around, and I just don't see it happening with what's on the trajectory they're on. Okay, so I want to be very protective of the word decentralization. That means a validating node everywhere. Literally every network device on the planet should get a full node. That implies that on-chain data storage is super expensive and that small blocks are necessary. This is something I feel extremely strong about because we need to resist nation-state actors such that people don't starve and people don't get hyperinflated and all these very ugly things that we know happened. Okay, and so because we have to make things hard to change, protocol updates have to move very, very slowly. But what we will achieve is that hopefully in the future, 1 trillion different devices on the planet, they're going to be regulating our money. And that's specifically low-cost devices like a Gumball machine. That's all I have.